In my previous video, I had discussed argument principle. In my previous video, I had discussed what is the argument principle and some example based on argument principle. In my previous video, I had seen in argument principle, by argument principle, we can solve this type of function. Today's goal of this lecture, today I will see more properties based on argument principle and some more example based on argument principle. Actually, this topic is very important for any competitive exam, also for higher study. Okay? Let's see. At first, statement of argument principle just as a review. We all of us know in my previous video I had seen this type of function on a simple closed contour C 1 over 2 pi I integration f prime z over fz equal to n minus p, where n or p are respectively number of zeros and poles of fz inside the contour C. First question, actually today I will see basic some more example based on this theorem. First question, evaluate the integration C f prime z divided by fz, where fz equal to z square plus 1 whole square divided by z square plus 3z plus 2 whole cube, and here the contour C equal to mod z equal to 3. Then the poles of f are z square plus 3z plus 2 whole cube. This is equal to, that imply z square plus 3z plus 2 equal to 0. That imply z plus 1 and z plus 2 equal to 0. That implies z equal to minus 1 and minus 2. Here minus 1 and minus 2 lies inside the circle. That means poles lies inside the circle, and order of the pole, multiplicity of the pole is 3. That means each multiplicity is 3. Each pole has multiplicity 3. That means the number of poles equal to 3 plus 3 equal to 6. I hope my all viewers have understood the number of poles. Then we have to find the number of zeros. The number of zeros, we have to find the number of zeros. Here fz is z square plus 1 whole square. Z square plus 1 whole square equal to 0. That imply z equal to plus minus I. And plus minus I means this is I and this is minus I. This is also lies inside the circle C with multiplicity 2. Therefore, number of zeros plus 2 equal to 4. Therefore, the answer would be 2 pi I times number of zeros minus number of poles. Here number of zeros is 4 and number of poles is 6. Therefore, this value would be 2 pi I times minus 2. That means this value would be minus 4 pi I. Which is very interesting, which had come GATE 2003 exam. The question is, let gamma be a curve r equal to 2 plus 4 cos theta where theta lies between 0 to 2 pi. If I1 equal to dz over z minus 1 and I2 equal to dz over z minus 3, here gamma equal to be the curve r equal to 2 plus r cos theta. That means the circle is 2 plus 4 cos theta. That means the circle is z equal to 2 plus 4 cos theta types. That means z minus 2 less than equal to 4. So here the point 2 with radius 4, that means this is, consider this is 6 and this is minus 2. This is be the circle, and I1 equal to dz over z minus 1. Here f equal to z minus 1 and f dash equal to 1. Here we can apply the argument principle because f dash equal to 1 and number of zeros of f, number of 0 of f equal to z minus 1 equal to 0, that implies z equal to 1. This is the number of 0. Therefore in this function there is no pole. Therefore I1 equal to, by argument principle, 2 pi I and number of zeros is 1. That means this value is 2 pi I. And I2 equal to dz over z minus 3. Here also consider f equal to z minus 3, then f dash equal to 1. So also here we can use the argument principle. Therefore, since f equal to z minus 3, therefore also here number of zeros of f is 1. So I2 equal to also 2 pi I times 1, this value is 2 pi I. Therefore, here I1 and I2, these both value are same. I hope my all viewers have understood this question easily. Okay, OL. Next question, let gamma k equal to the set k e to the power I k theta, where theta lies between 0 to 2 pi. For k equal to 1, 2, 3, then which of the following are necessarily declared? Option 1, 1 over 2 pi I integration gamma k 1 over z dz equal to 0. And here the question about gamma 1, this is the question about gamma 2, and this is the question about gamma 3. Gamma k equal to k e to the power I theta. At first consider gamma 1. Gamma 1 equal to e to the power I theta, because here k equal to 1. Then mod gamma 1 equal to modulus of e to the power I theta, that value is 1. That means z equal to mod z equal to 1. For gamma 1, 1 over 2 pi I integration 1 over z dz. For gamma 1, consider fz equal to z. Then f prime z equal to 1, similar to before. Therefore, since fz equal to z, so number of zeros only 0, number of zeros is 1. So this value is 1 over 2 pi I gamma 1 over z. This value is 1 because number of zeros is 1 and number of poles is 0. Next, 1 over 2 pi I with respect to gamma 2. Here gamma 1 equal to e to the power I theta. Then gamma 2 would be, since k e to the power I k theta, then this value would be 2 e to the power 2 I theta. 2 I theta. Then modulus of gamma 2 equal to, this value would be 2. And here notice theta lies between 0 to 2 pi. Since here 2 theta, so 2 theta lies between 0 to 2 pi. Therefore, this value would be sorry, 2 theta lies between 0 to 4 pi, not 2 pi, 4 pi. So this value would be similar to before, this value would be 1. Since here with respect to gamma 2, since here 2 theta lies between 0 to 4 pi, not 1 rotation, here 2 rotation would be used. So this is equal to, this is would be times 2. That means this value equal to 2. So option 1, this value equal to 1, this is right option. That means option 2 is a 2. This option 2 is a right. And option 3, this value is equal to 2. That means this is with the wrong option. And gamma 3 equal to 3 e to the power 3 I theta. That means mod gamma 3 equal to 3 and 3 theta lies between 0 to 6 pi. So this value would be with respect to gamma 3 1 over 2 pi I dz. Here would be not 1 rotation. Here since theta lies between 0 to 6 pi, that means here use 3 rotation. So this value would be 1 into 3 equal to 3. So option 4 is a right option. That means option 2 and option 4 is the right option. Next question, which had come CSIR NET 2023 exam. The question is the statement f be a meromorphic function on an open set containing the unit circle C and its interior. C is the unit circle which is containing, C means whole unit circle actually. And suppose that F has no zeros and no poles on C, and let NP and N naught denote the number of poles and zeros of F inside C. Then which of the following statement is true? Notice option 1, 1 over 2 pi I integration C z f dash over z f dz equal to n naught minus np plus 1. Here np denotes the number of poles and n naught denotes the number of zeros. Np denotes number of poles of the function f and n naught denote number of zeros of the function f. And f has no zeros and no poles on the C boundary. It has no zero on boundary. It has no zeros and no poles. And here use only the argument principle 1 over 2 pi I z f dash over zf. That means the function f is here consider the function g is equal to zf, and number of zeros of zf is zf times zeros, and that imply z equal to 0, f equal to 0, and f has n0 number of zeros. That means number of zeros of g equal to 1 plus n naught, and in zf only f has a pole, number of poles, because in z has no pole. F has np times np number of poles. That means z equal to, this is the number of zeros of g, number of zeros, and number of poles of g would be np. Okay, therefore 1 over 2 pi I zf dash over zf, this value is equal to n minus p, where n is number of 0 and this value is 1 plus n naught, and p is the number of poles and this value is minus np. So correct option is 1 plus n naught minus p, np. That means option 1 is a correct option, and option 2, option 3 and option 4 are wrong option. I hope my all viewers have understood this question easily. This is actually just statement. Next question, which had come GATE Mathematics 2020 exam. The question is, let fz equal to this product n equal to 1 to 17, z minus pi over n, where z belongs to complex number. Here gamma t equal to e to the power 2it, where t belongs to 0 to pi. If f prime z over fz, this value is alpha pi r, then what is the value of alpha? Here gamma t equal to e to the power 2it, that means mod gamma t equal to 1, and fz equal to product of n equal to 1 to 17 z minus pi over n. That means this value is z minus pi over 1, z minus pi over 2, z minus pi over 3 up to z minus pi over 17. And the zeros of fz are pi, pi over 2, pi over 3, pi over 4 up to pi over 17. Okay, and the zeros which lies, the zero which lies inside the circle gamma t equal to 1, these are pi over 4, pi over 5 up to pi over 17. Okay, the number of zeros of fz lies in the circle gamma t is 14. Since gamma t equal to e to the power 2it, where t lies between 0 to 2 pi, this implies circle rotates 2 times and there exists no poles, so f prime z over fz dz, this value is 2 pi I times 2 times 14. That means this value is 28 times 56 pi I. This is the answer of this integration. I hope my all viewers have understood why argument principle is very important for higher study, also for any competitive exam. Okay, well, next. Therefore, the value of alpha is 56. Value of alpha is 56. Next example, let R equal to Z, the set Z equal to x plus iy, where x lies 0 to 1 and y lies minus 11 pi to 11 pi. The region would be such type. Here x lies from 0 to 1 and here 11 pi and here minus 11 pi. And that means the region would be such type. And in the complex, all direction would be anti-clockwise direction. So direction would be such type. So this is the region. And the value of the integral is 1 over 2 pi I on this region gamma e to the power z over e to the power z minus 2. Here fz equal to e to the power z minus 2. Okay. Therefore, f prime z equal to what? E to the power z. That means this is the argument principle used here. And the root are zeros of fz is e to the power z minus 2 equal to 0. That imply e to the power z equal to 2. That implies z equal to log 2 plus 2n pi, where n belongs to integer. And the number of zeros is this type, log 2. Log 2 plus 2 pi I, log 2 plus 4 pi I, log 2 plus 6 pi I, log 2 plus 8 pi I, log 2 plus 10 pi I. Here and here would be minus. That means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are number of zeros 11 times. So the value would be, number of poles is 0, 11. Okay, this is the value of the integration. Next question. Let C equal to Z belongs to C such that mod Z equal to 2023 with a circle in the complex plane with center at origin and radius 2023, oriented anti-clockwise direction, and fz equal to e to the power pi z over 2 minus e to the power minus pi z over 2. Then evaluate this value. And this question had come in N.B.H.M exam 2023. Here fz equal to e to the power pi z minus 1 over e to the power pi z over 2. That means this is equal to e to the power pi z minus 1 divided by e to the power pi z over 2. And zeros of fz is, after calculating this value, would be z equal to 2n I, where n belongs to integer. And here the circle mod z equal to 2023. That means the circle with center 0 of radius 2023. Here 2023, 0, here minus 2023, 0, here 0, 2023, and here 0, minus 2023. And the orientation would be anti-clockwise direction. Then number of zeros. Here number of zeros, this is very interesting. When n equal to 1, then this value would be 2i. When n equal to 2, this value would be 4y. This would be continue. When n equal to 1001, then this value would be 2022. When n equal to 1012, then this value would be 2024. That means here 1011 times 0, here also 1011 times 0. That means number of 0 is 1011 plus 1011. This value would be 2202. Sorry, here I have done one mistake. Here I have considered from n equal to 1, but 0 also would be the zeros. So this value would be 2022 plus 1. 0 also would be included. So this value would be 2023. Since e to the power pi z over 2 not equal to 0 for all z belongs to C, that means that imply fz has no poles. Therefore, so the value of the integration is 2023. I hope my all viewers have understood why the argument principle is very important. Okay? Oh well. Today I will stop here. In my next video, I will discuss Rouchy's theorem. Rouchy's theorem also very important for any competitive exam. But at first I will highly recommend you please see today's video with pay attention. Okay? See you soon. Stay safe and stay positive always. And don't forget to subscribe my channel for more videos. Thank you so much.